Imagine waking up tomorrow to a completely silent phone. No Wi-Fi, no mobile data, no cell signal. The towers go dark, and the traditional networks we rely on collapse. In a total blackout, standard messaging apps become useless. Yet, amidst the silence, millions of people continue texting, sending images, and coordinating in real time. They manage this through an application called Bitchat. It operates completely independently of the internet. By removing the central server entirely, the developers eliminated the very mechanism that makes a network-wide kill switch possible. During mass demonstrations across India, local authorities frequently restricted internet access to control the flow of information on the ground. As protesters bypassed the blackout using offline tools, the Indian government intervened. They invoked Section 79 of the Information Technology Act, compelling GitHub to scrub Bitchat source code repositories from the web. Traditional communication is easy to monitor and disable because it relies entirely on physical choke points. Authorities can simply order a telecom provider to power down a specific tower. That regulatory action revealed a modern geopolitical friction point. A centralized state apparatus was trying to silence a network that has no physical center to attack. This untraceable architecture caught the attention of Jack Dorsey, who became a prominent backer of the open source project, aligning with his push toward decentralized technology. For over 100 years, humans built communication networks by routing signals through massive hubs. From early telegraph relays to mid-century telephone switchboards, every upgrade in technology kept the actual routing power firmly in the hands of the infrastructure owners. The developers achieved security by extracting the internet from the equation entirely, bypassing the need for a traditional messaging server. By stripping away the centralized databases, the authority over who gets to send and receive information transfers from a corporate provider directly to the individual. In a dense environment like a packed stadium, when tens of thousands of people text at once, standard cellular towers overload and crash. When the central hub shatters, Bitchat activates a Bluetooth mesh network. Every smartphone converts into a miniature broadcast tower. Acting as relay nodes, they form a localized web. Through hop count, an encrypted message bounces across these devices to reach its target without Wi-Fi. The phones in the stands form the new network. The human crowd itself physically becomes the telecom infrastructure. This creates complex challenges for law enforcement. Authorities have raised concerns about the lack of user locks and the encryption inherent to a serverless environment. Without a central database to subpoena or an internet service provider to monitor, investigators cannot track communications between organized crime syndicates or groups operating on the mesh. The application also carries its own inherent risks. It remains beta software, and independent researchers have pointed out vulnerabilities, including a risk of identity spoofing within the network. The privacy generated by a decentralized mesh network sits in direct conflict with a modern state's obligation to maintain security and monitor criminal activity. The regulatory action in India exposed a severe limitation in trying to police this technology. The legal notice could only force GitHub to remove the central source code repository from the web. Once the application is downloaded, it lives directly on the user's hardware. People can easily share the file from phone to phone via Bluetooth, making a functional ban nearly impossible to enforce. That exact resilience makes the software critical during major environmental disasters. When cyclones or earthquakes hit and legacy power grids and cell towers are ripped apart, these offline networks allow rescue teams to coordinate. Engineering a system to survive the total destruction of physical infrastructure naturally creates a tool that is highly resistant to state censorship. This technology demonstrates a model for localized, offline human grids that can operate independently of multi-billion-dollar corporate telecom structures. The physical infrastructure for this network already exists in the billions of smartphones sitting in people's pockets. The path forward for global communication routes around centralized corporate and state control, returning the physical ownership of the network to the users themselves.